Hello everyone and welcome back to our channel, and in today's video we will be starting creating contents about the applications of the derivative. But before going to the applications of the derivative, we need to understand first this continuous function. Question is, what are these continuous functions? When you are talking of continuous functions, there are two ideas that you should remember, and these two ideas that you should remember when we are talking of continuous functions are the following. The first one, continuous functions, their graph do not contain any holes. So the first idea, these are functions that does not contain holes. And the second one, they are functions in which they do not have any jumps. So what are these holes and jumps? If we will examine, for example, a particular function in a graph, let's say this graph here, okay, an increasing graph, obviously an increasing graph, but if you will observe the graph, it has a hole in between. So this one here is the one that we call a hole, and there is a gap from this part up to this part, and this one is what we call a jump. And both this jump and this hole signifies discontinuity. Okay, so it means discontinuity. So whenever you see a hole and a jump, it means that the graph has a discontinuity. Okay, so in other words, if this one y equals f of x is a function that has a hole and a jump in between, or in their part, we may say that this function is not continuous. So this is not continuous. So in other words, what are functions that are continuous? I have here another illustration. For example, we have this type of graph. Is any squiggling graph here. Let's say y is equal to f of x. If you could observe this graph, there are no holes in its part and there are no jumps or gaps in its part, starting from the bottom up to the top. So this is an example of a continuous function. Simple as that. I hope you understand. That's very easy. So this is a continuous function, no holes, no jumps, and this is an example of a function that is not continuous because it contains holes and it contains jumps. Okay? Alright. Moving on. You need to understand also ideas about intervals. Intervals are some parts in a number line that tells you something about the coverage of a certain number or a certain numbers in the x-axis or in a number line. And the first interval that you should know is the one that we call the closed interval. By its name alone, you will have a clue because it is closed. For example, I have here a number line, and of course in a number line the center is 0, and we have 1, 2 and 3, positive on the right and negative on the left. For example, we have here an interval. Let's say x is greater than or equal to 1 but lesser than or equal to 5. So this is a closed interval. Okay, or let me change this 5 to 3 because our number line here is only up to 3. Okay, so if you will rewrite this one in another form, this could be written as 1 comma 3. Take note, we are using here brackets. Okay, brackets, close square brackets. When you are talking of closed interval, we are using square brackets. So where's the location of this 1 and 3 in a number line? it's here, positive 3 and positive 1. So we can enclose this one, this coverage from 1 to 3, and we can indicate them as a closed interval. So in a closed interval, the endpoints are included. Okay, so endpoints are included. Okay, close. So in other words, the endpoints are included. However, there are some cases that the endpoints are not included, and we say that an interval is open. So an open interval, when we say that endpoints are not included. Okay, so in this example, we can rewrite this one as x is greater than 1 but lesser than 3. Okay, and in a number line, you will locate 1 and 3. Let's say this is 0, this is 1, and this is 3. So endpoints are not included, in other words, open in the endpoint. So we will have here a parenthesis. Okay, because this one, we can rewrite this as open parenthesis 1, 3. Take note, in a closed interval, we are using a bracket, but here, in an open interval, we are using parentheses. Okay, so all of the given points in between 1 to 3, excluding 1 and 3, if you are talking of an open interval. Okay, another type of interval that you should know is the one that we call as half open or half close. Okay, half open or half close intervals. Okay, by its name alone, you will have an idea how this interval looks like in a number line. For example, I have here an interval x is greater than or equal to 1 but lesser than 5. Okay, so to represent that one in a number line, we will locate 1 and 5. Let's say 1 is here and 5 is here. So close on the left side but open on the right side. So on the left side, we'll be using a bracket, and we'll say here, we'll write here 1 but open on the left side, so we'll have parentheses. So this is half open. So close in 1 but open in 5, and we will include values from 1 up to this point, 4.999 if you would say, excluding number 5 because it is open in 0.5. This is what we call half open, half closed, because it is closed on the left side but open on the right side. We can reverse the inequalities, like for example, another interval x is greater than 1 but lesser than or equal to 5. So in the number line, we could represent this one by reversing the inclusion from 1, but this time we have now 5. So in other words, open in 1 but close in 5. So open in 1, endpoint is not included, or 1 is not included, but 5 is included. So this is the reverse of our first illustration in the other number line. So in other words, we can rewrite this one as open in 1, close in 5. So these two examples here are examples of what we call half open and half close intervals. So far so good. Those are the very basic things that you should know before going to the applications of the derivative. It is all about the idea on a continuous function and the idea on the interval. See you soon in the next video. Thank you very much.